Professor Belfrost's computer science class is back!
Hi, welcome back. And here's Professor Belfrost's class on computer science. And today we are going to explore another concept on computer science, continue our last lesson. And if we are already ready for today's episode, then let's go. Great. I'm very happy to meet you again in my class. So today I'll start discussing about external memory. So external memory is another kind of memory too. We have previously discussed in our previous lessons about cache, also internal memory. They are also one kind of memories. So yeah, in external memory chapter, we'll discuss about magnetic. This is the most common one. Also, we'll discuss about RAID. Okay, redundant array ID. Also, we have optical memory with us, magnetic tape, and yeah, probably have some appendix to be seen. Okay, so here's the key points for this chapter. So magnetic disks remain the most important component of external memory, both removable fixed or hard. These are used in a system ranging from personal computers to mainframes and supercomputers. Okay, and to achieve greater performance and high availability, that we use RAID this technology. Okay, so RAID actually RAID is also used for um, okay for sustainability and other things. Also, we'll later see about this. And also, optical storage technologies become increasingly important. And while CD-ROM has been widely used, there are also like writable CD and DVD. And yeah, okay. So yeah, the main concept that actually will be explained in this chapter is what called RAID, which is a redundant array of independent disks. Okay, let's start. Maybe this will take two video to explain this whole chapter. Okay, the first one is magnetic disk. So, what is a disk? A disk in computer terminology is actually a circular plate constructed of non-magnetic material called the substrate and coated with a magnetizable materials. And traditionally, the substrate has been aluminum or aluminum alloy material. Okay, and more recently, that glass substrates are used, and this provides certain benefits. Okay, like improvement of the uniformity, also significant reduction in several defects. Also, we have ability to support lower fly high, also better stiffness and ability to withstand shock and damage. And let's see a little about magnetic read and magnetic read and write mechanism. So our data are recorded on and later retrieved from the disk via a conducting coil named head. Okay, so yeah, head. And in many systems there are two heads, a read head and write head. Okay, and during a read or write operation, the head is stationary while the plater will rotate beneath it. And a write mechanism implies the fact that electricity flowing through a coil produces a magnetic field, and then electric pulses are sent to the right head, and the resulting magnetic field or magnetic pattern are recorded on the surface below, and with different patterns for positive and negative current. Okay, so the right hand cell is made of an easily magnetizable material and it's in cylinder, rectangular, you see, rectangular donut with a gap along. Okay, this is right hand. Okay, with a gap along one side and a few turns of conducting wire along the opposite side. Okay, then the electric current induces a magnetic field and which in turn magnetizes a small area of the recording medium. Reversing the direction will reverse the direction of the magnetization of the recording medium and give you a different pattern. Whereas for red, it explains the fact that a magnetic field moving relative to the coil will produce an actual current in the coil. So this is just a reverse process, okay? And when the surface of this passes under the head, then it generates a current on the same polarity as the one already recorded. And the structure of the head for reading is in the case essentially the same as for writing, and therefore the same head can actually be used for both. And contemporary this system use a different write mechanism mechanism that require a separate right hand in position for companies close to the right hand, and the right hand consists of a partially shielded magnetoresistive or MR sensor. So this MR material has an electrical resistance that depends on the direction of the magnetization of the medium moving under. So let's see about data organization and formatting. Okay, so yeah, the head is a relatively small device that capable of read and write. Okay, and this gives rise to the organization of data on a player in concentric set of rings called track. Okay, so we have track, sector, and also gap. Okay, so yeah, each track is of the same width. Okay, and there are thousands of tracks per surface. Okay, so adjacent tracks, okay, this is track, are separated by gaps. Okay, and this will prevent or minimize the errors due to misalignment of the head or simply interference of magnetic field. And the data are transferred to and from the disk in sectors. So what is sectors? Is sectors. Okay, sectors 1, 2, 3, 4, 5, 6. Sector N. Okay, and there are typically hundreds of sectors per track. Okay, and to avoid imposing unreasonable precision requirement for an system, the adjacent sectors also separated by what called intra-track gaps. Okay, intra-track gaps. Okay. Some way must be found to compensate for variation in speed so that the head can read all the bits at the same time, and this can be done by increasing the spacing between bits of information recorded in segment of things. And this is what called constant angular velocity, CAV. So we see, yeah, this is CAV, and this is later what called multiple zone recording. With CAV, then this is divided into a number of pie-shaped sectors and into a series of concentric threads. And the advantage of using these kind of techniques is that individual blocks of the data is then can be directly addressed by track and sector. And to move the head from its current location to a specific address, it only takes a short movement of the head to a specific track and short wait toward the proper sector to spin under the head. But there is also what disadvantage of this system. There is the amount of data that can be stored on the long outer tracks. The only same as what can be stored on the short inner track. So it's actually quite not good thing for the two. And because density, the in bits per linear unit that increase in moving from the outermost track to the innermost track, then this storage capacity in a straightforward CFP is limited by the maximum recording density. Okay. And to increase this density, the modern hard disk system has utilized a technique called multiple jar recording, as shown or depicted in the figure B in the figure 6.3. And with this, the surface is divided into a number of concentric zones, and within a zone, that number of bits per track is constant. Okay, zones farther from the center, this is the center, contain more bits, more sectors than zones closer to the center. And yeah, the sum means is needed to locate a sector position with the track. And clearly there must be some starting point on the track and way of identifying the start and end of each sector. And these requirements are handled with control data recorded on the disk. Then let's see physical characteristic of external memory, the disk. I mean, okay. So there are several major characteristics of magnetic disk. The first one is that the head may either be fixed or movable with respect to the radial direction of the platter. So there are two types. In a fixed head disk, there is one right head per track, and all of the heads are mounted on rigid arms that extends across all tracks. Such systems are actually rare today. And in a movable head disk, mostly used today, actually magnetic disk is still being used today, though it's not very common nowadays. There is only one right head, and again the head is mounted on an arm. So the disk itself is mounted on a disk drive, which consists of the arm, a spindle that rotates the disk, and the electronics needed for input and output of binary data. So there are two types. Here you have non-removable disk and also removable disk. So a non-removable disk is permanently mounted in the disk drive, and the hard disk is in a PC is mostly a non-removable disk. For removable disc, this can be removed and replaced with another disc. And the advantage of the removable disc is that unlimited amounts of data are available with a limited number of disk systems. Also, we have what called a single-sided and double-sided disk. Okay. So actually, there are many types. Okay. And here's a component of this structure. You see the arm, the right hand. So we have a plater, we have a spindle. Okay. So some disk drives accommodate multiple players stacked vertically as shown figure above, a fraction of an inch apart. Okay, maybe you ask, isn't that this is dangerous? Yeah, sometimes it's dangerous. Okay, and multiplayer disks employ a movable head with one right head per player surface, and all of the heads are mechanically fixed so that all are at the same distance from the center of the disk and they move together. Okay, the set of all the cylinders, all the tracks in the same position on a player is called cylinder. Okay, and finally, the head mechanism provides a classification of the disk into three types, and traditionally, that the right head has been positioned at a fixed distance above the platter and allowing an air gap. Okay, so at the other extreme is a head mechanism that actually comes in physical contact with the medium during a read and write operation. This is used with a floppy disk. Okay. Yeah. So third type, that the head must generate or sense an electromagnetic field of a sufficient magnitude to write and read properly. And the narrower the head is, then the closer it must be to the platter surface to function. So what you see here is that to push the technology further, then what called Winchester disk has been developed. Okay, they are designed to operate closer to the disk surface than conventional rigid disk head, thus allowing greater data density. But the problem is that this. Okay. Yeah. So yeah, maybe I will not review a lot more. And let's see some of these performance parameters. Okay, so we have some. On a movable head system, that the time it takes to position the head at the track is known as seek time. And in either case, once the track is selected, and the control waits until the appropriate sector rotates to line up with the head, and this is called rotational delay or rotational latency. At the start of the seek time, and the rotational delay equals the X time, in which it takes to get into a position to read or write. And once the head is in position, then the operation is then performed, and the data transfer portion of the operation, then the time that required for this transfer is called the transfer time. Also, additional to the access time and transfer time, there are also several queuing delays, and this is also the parameter actually, because it actually must first wait in queue for the device to be available. Okay? And in some high-end system for service, a technique known as a RPS, or rotational position sensing, is used, and this works as follows. So the seek command has been issued, and the channel is released to handle other I/O operations. And when the seek is completed, and the device determines when the data will rotate under the head. As that sector approaches the head, then the device tries to re-establish the communication path back to the host. And if either the control unit or the channel is busy with another I/O, then the connection attempts fail, and the device must rotate once again, one whole revolution, okay, before it can attempt to reconnect, which is called the RPS. So this is another parameter, RPS means. Okay, so we have the in-depth discussion here. We have seek time. Okay, it has been shown to you before briefly. Seek time required to move the disk arm to required track. Okay. So seek time consists of two key components: the initial startup time, the time taken to traverse the tracks that have to be crossed once the access arm is up to speed. Okay, but actually with parcel time. It includes a selling time. Oops, it's hard for me to do. Okay, and yeah, much improvement has been done, and typical effort time on the contemporary hard disk is under 10 milliseconds. They have rotation and delay, yeah, and this um, rotate averagely ranging from 3600 rpm to yeah 20,000 rpm. Okay, so the rotation delay is about 1.5 milliseconds. Okay, and next one we have transfer time, and this can be calculated in the fashion as shown by the equation. Also timing comparison, maybe we can skip for this. This is just an example. Okay, okay, then the next discussion for this chapter is rate. Okay, rate, yeah, this one. With the use of multiple disks, there is a wide variety of ways in which the data can be organized and in which redundancy can be added to improve reliability. Okay, so reliability is the important parameters here. Okay, and fortunately, the industry has agreed to use a scheme of multiple disk database design, which is called redundant array of independent disks. Okay, and RAID scheme now consists of 7 levels, 0 through 6. So there are three common characteristics. RAID is a set of physical disk drives viewed by the operating system as a single logical drive. Second is that data are distributed across the physical drives of an array in a scheme known as striping, described subsequently. And redundant disk capacity is used to store priority information, which guarantees data recoverability in case of a disk failure. Okay, and the detail of the second and third characteristics differ from the different RAID levels. RAID 0 and 1 do not support the third character, so this is the exception. Okay, so the unique contribution of the RAID proposal is to address effectively the need of redundancy. Although allowing multiple heads and actuators to operate simultaneously achieve higher I/O and transfer rate, then the use of multiple devices increase the probability of failure. And then we need to make use of RAID to store parity information that enables the recovery of data loss due to possible disk failure. Okay, so we have some this is a terminology used in RAID. We have striping, mirroring, parallel access, and independent access. I'll leave it for you to learn it by yourself, because yeah, they are too long if I want to explain it one by one. Okay, so yeah, they are used in different ways. Okay, so here are RAID 0, which is the non-redundant type. We have RAID 1, which is the mirror type, and RAID 2, which is redundancy through the Hamming code. Hamming code has been discussed in the previous chapter. Okay, so each RAID level strong points is highlighting by the darker shade. Okay, and let's scan one by one. So RAID level 0 is actually not a true member of the RAID family because it doesn't include a redundancy to improve performance. But there are a few applications, such as supercomputer, which performance and capacity are primary concerns, and low cost is more important than the improved reliability. And for RAID 0, the user and system data are distributed across all the disks in the array. This has advantage actually. If two different I/O requests and pending for two different blocks of data, then there is a good chance that it's requested the blocks are on the different disk, so they can be issued parallel. But okay, it can go further than simply distributing the data across this array. So the data are striped across the available disk. This is another figure on another system of RAID 3, which is bit interleaf parity, RAID 4, which is block level parity, RAID 5, which is block level distributed parity. We'll also later see there is some combination like RAID 1 plus 0, 0, 1, so on, so on. Okay, 5 and 6 together. Just yeah, there are some kind of combination they use. Okay. So logical disk is divided into strips, and this strip may be physical blocks, sectors, some are units. A set of logically consecutive strips that maps exactly one strip to its remember is referred to as stripe. Okay, you see? Strip, stripe. Okay. Strip, 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 strip. So this is data mapping for array level 0 array. So the advantage of this layout is that if a single IO request consists of multiple logical contingent strips and up to n step for the request can be handled in parallel, and this will reduce the IO transfer time. RAID 0 can also use for high data transfer capacity, okay, because actually it depends critically on the request pattern of the host system and the layout of data. Okay, so yeah, for application to experience a high transfer data and to try high transfer rate, then two requirements must be met. The first one is that high transfer capacity must exist along the entire path between the host memory and the individual disk drive. And the second requirement is that the application must meet IO requests that drive the disk array efficiently. Okay. The second use is for high IO request rate. In a transaction-oriented environment, the user is typically more concerned with the response times than with transfer rate. Okay, so the IO time is dominated by motion of the disk heads and the movement of the data. So yeah, a disk array can provide high IO execution rate by balancing the IO load across multiple disks, and this can be achieved by multiple IO requests outstanding. Okay, and in turn it implies that there are multiple independent applications of single transaction oriented application that is capable of multiple asynchronous IO requests, and this is where we can make use of RAID level 0. Then we'll discuss RAID level 1, 2, and 3. The next one, 4, 5, 6, 7, and 4, 5, 6 will be on discussion of the next video. Okay, so RAID level 1, RAID 1 differs from RAID level 2 through 6 a way in which the redundancy is achieved. So in the other RAID schemes from level 2 to 6, then the sum of parity calculation is used to introduce the redundancy. But for RAID 1, the redundancy is actually achieved by simple expedient of duplicating all of the data. So it is done by data striping as in RAID 0. But in this case, each logical strip is mapped to two separate physical disks, so that actually every disk in the array has a mirror disk that contains the same data. Maybe you say, oh, this is actually redundant. Okay, it's wasteful, right? Yeah, but we'll later see how this make use of. Okay, so there are a number of positive aspects to the RAID organization. The write request can be serviced by either of two disks that contains the requested data, which have a minimum seek time plus a rotational latency. A write request requires that both corresponding strips can be updated, but this can be done in parallel, and write performance is dictated by the sum of two writes. However, there is no write penalty for RAID 1. And recovery for failure is simple. Okay, the data may still be accessed from the second draft. But the principal disadvantage of RAID 1 is that the cost that it requires twice the disk space of the logical disk that it supports, and therefore RAID 1 configuration is likely to be limited to drives that source system software and data and other highly critical files. Okay, and last one may be RAID level 2. Okay, RAID level 3 will be on next video. Okay, so RAID level 2, for RAID level 2 and 3, actually it makes use of parallel access technique. Okay? So in a parallel access array, all member disks participate in the execution of every IO request. And typically, the spindles of the individual drives are synchronized so that this head is in the same position on its disk at any given time. And this also makes use of data striping. And in the case of RAID 2 and 3, the strips are very small, often as small as a single byte of word. And with RAID 2, then an error correcting code is calculated across corresponding bits on each data disk, and the bits of code are stored in the corresponding bit position on multiple parity disks, and this mostly make use of having code. Okay, although Rate 2 requires fewer disks than rate 1 is still rather costly because the number of redundant disks is actually proportional to the log of the number of data disks. And in a single RAID, then all disks are simultaneously accessed. Okay, if there is a single bit error, then the controller can recognize and correct the error instantly, and the RAID access time is not slow. On a single write, all data disks and parity disks must be accessed for the route operation. So it only will be an effective choice in an environment in which many these errors occurs. Okay, though we have this reason, but RAID 2 is actually overkill and is not implemented. Okay, maybe there for today. Before I end the video, so here's a quote from Maya Angelo. My mission in life is not merely to survive, but to thrive. Okay, that's our lesson today. And that's all our lesson for today. Thanks for watching. And here's your to-do list. So please subscribe, give a like, comment, and share this video to your friend. I'll be back on every Monday on the same class in computer science. And don't forget to visit our website at https://science with xyz.unux.com. Keep watching and be thoughtful. Goodbye.